Okay, now we've seen so far like the basics of select something from where. When we have like, these are the basic things that we started using, and we were using those. And we're also, what we were talking about, if we would like to compare if something is null, we're not going to be using equal, we said is. And we saw that there's in the condition in the where we can use between, we can use more than one table by using commas and so on. So these are the basic SQL. Now there are more things that we started talking about yesterday, which is the in. When you have some kind of a list, this list can be manual, where you can put your own list yourself, like what we did basically last time, or it's the result from a query. But we said, if you remember, there's like one condition for this nested query to work, that is I said there's something important about this before you can use this in nested query with this in or not in. We should declare? No, we don't declare. We will calculate the result in the where, but there's something related to that, but that's not about. When we said in, yes, we should have one thing, because we compare one attribute, one column, if it's in a list. And remember, we said that this list can be manual, like this, something like this. So if the ID is in one of these lists, then it's going to be then displayed. But I can also have the list to be dynamic, which is not the result of a query. And in this case, I have to just put one column here. I cannot put two or like many with the star. Yes, a question?
How about I want the ID and the name? Where ID and name.
If you'd like to put the condition on two, then you put two of them together, ID and then whatever, age, and then you put these two as well here, something here that has this column 1 and then another column 2, which normally should have the same meaning, so you don't have to be able to deal with them, to compare them. So this is the in or not in, the same thing, and this will allow you to have a lot of more advanced queries, and sometimes these are the type of queries that you might want to work with. And there's also, and this is the example when you have like more than one column. If you would like to have more than one column, of course you have to have the exact same number in the inner query than in the condition. There are other things that you can use too. You can also use these subqueries with these any or some, or with the greater than, lesser than, or like for example like this. If you look at this query over here, can you tell me what's the question this query is trying to answer? So what do we get from this query? What's the result of, what's the question that this query is trying to answer? This is the first name and last name of all employees that
have salary bigger than
have a salary bigger than something. Well, that's a good start.
That have a salary greater than those in department number 5.
That have this, so list all the employees, the first name and last name of all employees whom their salary is greater than any salary of all the employees in department number 5. So because this is going to give you all the salaries of employees of department number 5, and would like to display all the employees that have a salary greater than all of these. So this is going to show us this type of query. Now of course this I can use all or some, or this is the thing that I can use, greater than, lesser than, equal. All these are also possible with these nested queries. So that's the thing. Well, this is an example with the in again. There's something else that I would like to talk about, which is something called correlated nested queries. Now we've seen this it's like they're independent, right? We take these inner ones and then they give us the result. Based on those ones, the inner one, we can get the outer query. Now there's some queries that are related to each other using some kind of keywords like exists or not exists. And let's have a look at this thing. Can I see exist? No, there's no example with that exist. But yeah, I want to try to find one. SQL exists example. Okay, let's just take the first one that we have and see if it makes sense, if it's easy to follow. Okay, and okay, let's see the query first. Okay, let's have a look at this query. Now we have these two tables. This is customers, customer ID, last name, first name, favorite website, and then we have orders, order ID, customer ID, and then the order date. Now check this one. Select star from customers where exists, and this is the thing about the exists. Exist doesn't compare the content of a column if it's somewhere else. Exist checks that there is a relationship that exists. But look what is happening. Look at this inside nested query. Select star from orders where customers.customer ID. So did I mention that in the from there's the table customers? No, I did not. And yet I can access the customers because it uses this exists. So what happens actually, you just look at select star from orders. So I'm just looking here, these are the orders. I'm looking at the orders.customer ID, this one is existing in this customer ID. If this is true, then I'm going to display all the information about that customer. So this is what happens. I'm displaying everything from a customer, but not all of them. Only those that there is a connection between these two queries, where this gives me the customers, this gives me the orders, and this condition is comparing from the customers, the customer ID, and the orders, the customer ID. So what happens basically is just we go in the nested loop, in the nested query first. We start with this first one. What is this customer ID? That's the one. Is this one exist in this? Yes, obviously. So I'm going to display all the information. So I'm going to display this guy. Then the next thing, next row, I'm going to compare the customer ID in the orders. Is it equal to this one? Well, all of these basically are going to be equal because this is a foreign key normally that points to the customer ID. So all of these are going to be able, but maybe I should have done it differently by looking first here, because this condition is not going to be true if I look at from the side of the customer. Now this customer ID 4000, does it exist here? Yes, it exists. So I'm going to display this. 5000, yes. 6000 though is not there, so I'm not going to display this one. 7000, yes. 8000, yes. So this 6000 and this 9000 are not going to be in the result, and the result is going just to be something like this. The main idea is now this exists. What it does, it just connects the two queries together, and that's the exist or not exist. For example, if I put this not exists, then the result would be the two guys that were not part of the results if it existed. So that's this exists, what it does. And that's why they call that this correlated nested queries, because they are related to each other, the queries related to each other. Yes, your question?
The from. You only put the customer.
The from.
Yes, for the first.
Yes.
Don't you have to put also product?
The orders, you mean?
Yes, the order.
No, because I mean this exists. Just checks if there's a relationship, basically.
Oh.
So that's why we don't need to put this here, because the order is in the nested query. So basically what you're saying, display all the customer that exist, they have a relationship between the customer and the order. And that's what this actually says. And this is different from the in, not in, etc. Is that okay? Now these are the main things that we're going to be focusing on during this course, and we're going to be doing some exercises. But before that, I just would like to talk about some other things, even in the simpler select from where, that we can use, especially with text, that there's some couple of things that we can do. So I'm going to go back here. I'll stop here because there's nothing more that I can make use of this here, besides the joining, which is something probably I can just talk about it using another thing or later. So I'll talk about that later. Maybe I'll come back. So now, before going to those more complex, I just would like to remember to come back to the simple ones, because I did not mention some of the things that we can do with the simple ones. Now look at this simple query. Just select animal, water need from zoo, whatever. Now this gives us like this whole list. There's a way that you can limit the number of results that you would like to have. For example, I don't want to have them all. I just would like to have the first 10 or first 100, whatever. And you can do that by using something like limit. Where is it? Like this. For example, if you do something like this, the limit is, so select start from zoo, limit 10 means only display the first 10. And that's another thing that we can do with those queries.
First 10 or the highest 10?
No, the first 10. If you'd like to make the highest 10, you have to put your query to order them already, and we'll learn how to do that later. Because you can sort them, and then this will give you, if you sort them and then you limit, then it will give you only the top 10, something like that. So there's some other things, because in the where I did not mention that, and there are some kind of exercises that we could do with it, but I'm just trying to find if it's in here, or maybe no, it's not here. Let me just find it in like this SQL because this is something, yeah, maybe. Now this, sometimes if we'd like to check, put some conditions on text columns, and those type of conditions that starts with or end with or contain something, contain a letter or whatever. So these are the things that I can do with the like. Like is a keyword that is going to be allowing me, for example, if I do some condition like this, where customer name like this, that means it starts with A. And this means, the symbol means anything, 0 or many characters. That means if I have a customer name that has only A, it's going to be displayed. So, and there's another kind of wild card, which is this underscore. Underscore means one and only one character. If I put, for example, 1 instead of this percentage, I put the underscore. Now I'm saying, give me the customer name that starts with A and that has another letter, and that's it. If there's another one that has 3 letters, I'm not going to be seeing it. If there's one customer that starts with A but then has nothing, just only has A, it's not going to be displayed. So these are the things, yes.
Can I have more underscores?
You can put more 2 underscores if you mean that. In this case, it means it starts with A and then it has 2 letters, that any other letters, yeah. But it has to be letters, not empty. So this means 1 and only 1. This means 0 or many. And then you can do a lot of these things, like starts with, end with, something that has inside or at any position, or like this one, that means the first letter has to be something, the second letter is an R, and then whatever comes after. And this, what does this mean? it has to start with A, and then there's the second letter, and then it can be having something else, and then it has to be having a third letter. That means it's at least starts with A and has 3 letters, and it can have anything in between. 0, this means 0 or many letters in between. But that's kind of anything. Even special characters. These are texts, so it can be anything, any character.
Can't you put the underscore together?
Yes, you can put the underscore, but I think this was just meant to confuse you. There's no real need for that. Yeah. So, for example, like this means what? It just starts with A, ends with O. It doesn't matter how many characters it does have in between. It can be AO, and that will be fine, or A and then a lot of different things in between, and then O. So that's an example of this like. How? There's no matter? What do you mean by matter? I'm not understanding what matter means. What do you mean about matter? Oh, okay. It does not matter if it has a letter or not. Well, this means it can be no letters at all, or maybe 1 or 2 or 3 or 100. And many. Yeah, there's no limit. But this is not at least one. It's one and only one. Because if you say at least one, maybe it's 0 or 1. But it's one and only one. This one, if I put this like this, it means I have one character, then the second one is an R, based on this. And then the third one, it might not be any third one, or we might have a third and fourth and fifth or whatever. A underscore O, that means I'm looking for a word of 3 letters. The first one is A, the second one anything, and the third one is O. Yeah. So that's the kind of, the thing that we can see in the like. So we've seen limit, like, and we've seen now in the nested queries this in thing, etc. So let's just see. This is what I can find. These are the things that I can do to compare between the things. If I'd like to be equal or not equal, I can also use this one or this one. Basically, this one is mainly used as a compatibility with Microsoft, because they use that a lot, and this is pretty much with everybody else. This not equal, it means we're more comfortable with this because we've been using it that much, and then the rest is you've been using that. Okay. So what else? Yeah, this is an example with this like. Actually, this is here. So for example, if you look at this thing, it says like this should be like, okay, how many? 1, 2, 3, 4, 5. That means I'm looking for an animal that has 5 letters in the name, and it's not a tiger. So that's what this means. Because I put here, I know that it has 5. It cannot have like less than that. Those that have less than that do not qualify. Those that have more than that do not qualify either. I want 5 and only 5 letters. It can be any letter. Actually, based on this, it can be anything. It can even be numbers or special characters like commas, whatever. So if there was an animal that has a whatever dash, let's say, or a hash key or whatever, or exclamation mark in its name, and as long as it's 5 characters, that's fine.
So can we specify that to end?
To put like a number or something?
Yeah.
Well, then if you put a number, then it's not going to be a text, and then you're not going to be able to do these kind of things. If you'd like to put some kind of conditions, well, you have to put the conditions that, like, it starts from A to Z, and put some kind of the letters. If you don't want to, you put conditions here to only be letters. Not that I know of, like special characters. You have to do that yourself. You do it manually. like A less than A or greater than A and less than Z, for example, something like that. Wherever. Yeah.
So on this chart, it's like percentage, but it's like specified number of.
It's 1.
Yeah, I know. But
Fixed. 1. Minimum 1, maximum 1. It's 1.
it's not only, that doesn't hold only strings. I mean,
It's a string. A string can be any character. A character can be a letter or a number or a special character. So that's why since it's a string, it can be anything. Okay, so basically these are, I mean, the things that I want to talk about. This like and then the limit. I don't know if there's the other things we've seen them, the and or and things like that. It's yeah, something that we've seen. There is this in that we've been talking about, like if you can put the values yourself. In is kind of convenient if you don't want, if you have something like this, for example. You're looking for some specific values, you can just maybe, instead of putting this equal to this or equal to that or equal to that, this is going to be exactly the same thing as this. So if it's equal to this, you're going to be displayed. If it's equal to that, it's going to be displayed as well, and so on. So that's, I mean, the equivalent of the in. So when you have the values yourself, you can just do it this way. It's much faster. I mean, you type less things. But sometimes you don't have this list that is manually entered. You have to generate it from a query, and then you can put the result from a query. Isn't that right, Abdelaziz? Does it show on your phone, right? Oh, no? Too bad. Well, yeah. If you have this like, you can ask also not like. Same like in, not in, exist, not exists. Null, not null. So for example, is null, you can also say is not null as a condition. So everything can be not, basically. And yeah, I think that's fine. I mean, that's it. This is the example of the limit, and I think that's fine. This is, I'm going to put these websites, you see, have them, you can just enjoy doing some kind of exercises from those. There are some others that I'm going to also show you because they are also interactive, which means you can just go to that website, type your query, and then you can run it. It will give you the result, which is nice because you don't have to enter the data yourself, and then you can just test the query immediately. This is something where I'm going to show it to you basically later. Now, there's another thing that talking about those basic ones that we started talking about them before in the relational algebra, but we did not use them a lot in the SQL, which is these aggregation functions. Remember these max, min, sum, count? Now things come with them that are kind of nice, so I'm going to probably this is the one. Let me check this back here. Now now you're familiar with the limit, but what if I have something like this count? You remember what this count does? It counts the number of things, number of rows, number of.
No.
I'm sorry?
The number of the -1.
No, there's no -1. This is not the index. This is the number. Yeah, it just counts the number. Now, if you have, for example, this kind of flight delays, I don't know if you have this. Is this flight delays? Yeah, this is the start from flight delays. So this is it has a lot of actually columns. Now, if you say star, it doesn't mean any of them. We just count the whole line. We don't care about a specific column. Now, there's a difference between the star and the specific column, because if you put a specific column, it will just look at the values that are not null in that column. Let me repeat that. If you say, for example, select count, instead of the star, you put, I don't know, there's no null values here, but let's say I'm going to say year. I'm just choosing one of them that is year. Select count, year, from whatever, etc. This is going to give me the same result based in this case. However, if one of these is null, it is not going to be calculated. It's not going to be counted. But when you go for the lines, count star, it just go for the whole line, so it doesn't matter at a specific column. So generally, if you'd like to count the lines, you're not looking at a specific column, you just would like to know how many records do I have in this table, then you just do this count star. If you're looking for a specific column and you want only those that are not null, then you do this specific column. Now there's another thing is, maybe let me use this. There's another thing probably I should have, let me see if I can see some, do I have some, anything, do I have here? Let's say use company. And I'd like to select star from this employee. I don't know if I have anything in it. So it's empty. Okay. I'm going just to do something very simple. Let me just put this SSN is my primary key. I'm just going to put something in it, and let's keep the rest null because I don't care. I just would like to show something. Probably what I'm going to do, maybe the salary, or maybe this DNO. But no, this DNO is going to create some problems. Let me do something like that. The one is supervisors is 2, the 2 is supervisors is 3, and the third one is empty. I'm just going to apply this and apply, and now I have a problem because because this supervisor 2 doesn't exist already, so I cannot have it. Let's just do the opposite. Let's just keep this to be null. Can I just put it back to null? Well, it doesn't. Normally I should be able to set field to null, you see, but I'm okay, now I can. Okay, now this, for example, the 1 is the boss, the 2 has the boss, his supervisor is 1, and then the 3 supervisors is 2, and this way I'm not going to be having any foreign key violation. Oh, I do. Yes, because the super SSN cannot be null probably. And the field doesn't have a default value. Okay, no. So the field doesn't have a default value, and it's going to be painful. E1, 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 and I also maybe have the same problems with the rest. E3, 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 and then this is a birth date, and this should be a date, but probably it can be null, I hope. The address, probably not. Let me just add something. It doesn't matter. 1, 1, 1, and the rest. Probably this birth date, I don't want to be involved in dates. Let's see if it's going to be allowing me that. Okay, good. So now let me just execute this again. Now this is what I have. Now if I do select count star from employee, I get 3. Now remember, this I just count star, which means it just looks at the whole row. Now check this. If I do something like super SSN, now how many non-null value, non-null columns, non-null rows do we have? 2. So I'm expecting this to be 2. So that's what I'm trying to say. If you're looking for a specific column, only the non-null values should be counted. You put the specific column. If you're looking for the whole thing, okay, how many employees do I have? Don't use a specific column, because if it's one of them is null, it's not going to give you the correct number of employees that you have. So this is going to be the one that you have. There's another thing that you can do. But this time let me show you something with this. Look at this thing. Do I have something that is similar? Look at this. Imagine I'm going to do this. And this is also based on, I'm just displaying one column. They all have the same value. There's something that I can use to avoid repetitions. If I don't want to have repetitions, I can use distinct. Now, using distinct means it just avoid having the repetitions, and then you're not going to be calculating those ones that repeats. Now,
So if you do this, maybe you will get there's only one.
well, yeah, basically, how many sets do I have? How many different ones do I have? Now, this is just going to count me. There's only one type that I have. They're all, for example, male or all female or whatever. Let me just do this. Now, what you're saying, I'm going to have only one. Yeah, but is it a problem? I don't think so. Let me just, for example, these are all male. Okay. Now, if I just do this thing that I just did, select distinct this. Oh no, this one. There's only one, but what if it was, now we have some male and female. Okay, apply, finish. Now if I just do this count thing again, select distinct sex, is going to just to show me the ones that are not repeating. That's the only thing. If I remove the distinct, I'm just going to get them all with some repetitions. But if I'm not interested in repetitions, I just would like to know, okay, how many or what are what was the sex of the employees that I have in department number 5. So you're just going to see only okay, I have only male, for example, or I can have male and female. So it depends on the query that you're asking. I'm just showing you what you can do to get some information, but basically it's whatever you want to extract. You can extract whatever you want. Now, I just want to show you another thing, is that if I do this count star again, it doesn't matter about the columns. You just look at the whole row and count how many rows do I have. But if I do something like this, this is going just to count how many that are again there that are not null. But you can also remove repetitions, and if I do something like this, it just counts those that are not repeating, and that's the thing that I can do with this. Your question? So I made you forget your question.
How many male and how many female do we have? Like
No, what this do, it just counts how many different ones that are not repeating.
if you delete this thing.
Actually, this distinct just removed the duplication, so it did not count how many male and how many female. I just would like to know how many different values do I have in this column. That's it, regardless of I'm not counting them. If I want to count them, then I can do something else. But remind me of doing that when we're talking about in just a few minutes.
If you delete this thing,
If I delete what? Distinct?
yes, you count all of them.
It will count all the non-null values.
Yes, 3.
Yes. But if I do this, it just all the non-repeating non-null
All
values.
the possible.
On the non-repeating non-null values. Yes.
Does count return integer?
Does count what?
Count returns integer.
An int, yes.
Can I, if I accurate question, if I select star from employee, where ID in, then I got the select count like section.
I don't understand. Okay, let me just write down what you said. Select star
Select star
from employee
where
where
SSN, I guess.
SSN
Yeah,
is in
yeah, in, I mean, what's
the in.
the yeah, okay. And then select count,
In the inner query is select count.
like section maybe, from employee.
Count. Okay.
So the
Star, or you want a specific column? Okay, from employee.
what will happen? So
Now, what this is going to give you? It's going to give you a number, right? It's going to give you 3. Now it's going to say, I would like to see only the employee that has SSN equal to 3. So basically, I'm going to see one employee, which is E3, I think, that has his SSN is 3. But that doesn't make sense. But anyway, that's for example. But it's a good, just practical exercise. We can just do this, for example. Distinct sex. Now I'm going to see now E2, the employee number 2, because with the distinct is going to give me 2. This here gives me 2, right? Now there's one thing that I can do. If I'd like to count how many male and how many female do I have. Now what I'd like to do something different though. I'd like to display the sex and then display how many of each that are distinct. No, I don't want to put distinct because I would like to count the repetitions. Now when you do something like this is not going to work. Now, well, because you see what it does, it just counts all of them. It displays just one of them. But I know that there's male and female, but it just displays just one of them and then count all of them. Because if I'd like to do something, I'd like to group my calculations by this sex. Now what does this do? I'm just saying display the sex and the count of that sex with those that have the same values, count them. But then group. This calculation is not going to count all of the column, but only those that have the same values because of this group by. Now this group by, what it's going to do, let me just display maybe the employee. This group by is going to have a look at this, just this one, and look at all those that have the same values. It's going to group them and count how many are there. And it's going to display, for example, look at this one, M. How many M do I have? Count them, display them. Now F. How many F do I have? Count them, display them. That's what this is going to give us. So if I run this thing, I have 1 female, 2 males. And this group by is kind of interesting because even if I don't want to count, I can also group by. It also removes the duplication, but this time it just groups. It's the same thing. This group by is like this distinct. If I remove this and put distinct, I have this result. This one, no, this one did not count. But I can count here if I want to. With the other one I cannot. But there's another rule. Whatever you would like to get some kind of this is like an aggregation function, like max, min, average, count, all these. If you'd like to display something along with it, you have to group by it. So if you'd like, for example, to count how many employees that have the same department, then I can just put the DNO and I'm going to count DNO and count the SSN. And I have to group by whatever I would like to group by them. So now I'm grouping by the department number, and all those departments that are repeating, I'm going to display them. But in this case, what should I get? Because all of them are null. So I just count how many that are null. So let's go back to this thing. We have this count that counts. We have also the sum that just adds the values. Average, max, and min that finds the maximum and minimum. And the group by basically is just something that allows you to, whatever there's same value, you can group by it. You can group by one, or maybe group by more than one.
How does it know which one is for which? For example, when you count the male, how does it know this is for male?
It's just the value. It looks at the value. The value should be equal to the other ones. For example, now if I display this, when you group by the sex, you just look at this first value, M. Do I have more like these? Yes. Then I'm going to group by these ones.
But if you put count with it, it will show the count for each one.
Well, it does this and it counts. So I'm doing two things. So the group by is going to just group by them, and then if I'm counting them, it's going just to count. The group by is just going to remove those, put those that are the same together. So I can see only one of them. But then what am I going to do? I would like to sum them, or to count them, or to average them, or look for the max and min, etc. This is something that I can do with this aggregation function there. And for example, this is looking at the origin, and it groups an average delay based on the origin from the flights. So it's just going to give us the average of all the flights that have the same origin, basically like this origin is the same airport. So I just look at all these, and then look, all this airport number 1 are going to be grouped together, and then these values are going to be averaged. So that's how this group by works. Just looks at the values. If they're equal, it groups them together. And then if I count or I average, the operation is going to happen as well. So these are the aggregation functions. Well, you can just do more there. Now, if we've seen the select, the from, the where, the group by, and the limit. There's only one that is remaining, is the order by. This order by allows you to sort your results. So you can sort them based on ascending or descending. Now let me just go back here. I'm going to display this, and I'm going to order by what? Well, SSN, it's already ordered by SSN, as you can see. But if I do order by SSN, I'm going to see nothing is going to change, because they are already ordered by SSN. But what about just reversing the order? Now, by default, if I'm doing order by, it's in ascending order. If I don't type it, it will be there by default. So even now, if I'm typing it, it stays the same. But I can also reverse now. I don't want to have like in ascending order, descending order. Descending order means from the largest to the smallest, which means in this case, it will start with 3, 2, then 1. Now you can just put some, also this for having a limit, whatever, yes. Limit 1. So I just would like to have the one with the highest SSN, and it just displays only 1. Now what I can do something else. Let me order by salary, but not for now. Let me just go back this here. I'm going to change the salary. If some of them are going to be 1, and then this one is going to be 2, and this one is going to be 2, because I want to show you something different. Now you know what, I'm just going to make this 10 and then 2. So if I sort by salary, no, let's leave it at 1, 2, 2. I want to have the salary the same way. Yes.
When you sort order by descending order, you sort the bigger the descending.
Yes.
But when you delete it, you select staff from employee, it reverts back to the ascending order.
Yes, because by default, when it's stored in ascending order of the primary key.
Yeah, I know.
That's by default.
But when you reverse it,
When I reverse it by doing this descending,
yeah, you delete,
when you define the database and you specify that this is a primary key, by default, the values are going to be sorted from smaller to largest by the primary key. Now, if you want to change that, then maybe in the definition of the database, then you have to mention something that you would like to store that in a way that is different from the default way to store it. But this is out of the scope of this course. But you can do probably anything you want. Because the main thing is, why is it stored by the primary key? Because the primary key is the one that leads to all the other information. And we would like to be able to find the information quite quickly. So when it's sorted, and if you remember the data structure, when you have a tree and you'd like to find an element in a tree and that tree is sorted, it's much faster than if it's not sorted. So that's the main thing, the main idea. So it's going to be by default sorted based on the primary key, because it's going to be the one that is going to allow you to get to the information. But now, the point is, what I want to show you is that I can sort by more than one column. But to make this make sense, I'm going to sort by salary, for example. Now check the salary, because I changed that. Now the salary, I have 1, 2, 2, and then this is 1, 2, 3. Not big change though. So I want to have a different, something like this. I'm going to make this one here and then press enter, apply. So you will see what I'm trying to achieve here. So here you see this is 1, 1, because based on the salary, now I have 1, 3, and 2. Employee 1, then employee 3, and then employee 2, because of the salary. Of course, it's less than, but there's something else that I'm going to show you, because now what is the purpose of sorting with more than one column?
They're equal in one column. Look at the second.
Exactly. For example, here, when I put 2, that means if the salary, if 2 employees have the same salary, I would like them to be sorted by the SSN. Well, which basically this is what it is already. But I can also make it descending, and this is going to give me 2, 1, 1, and then it's going to sort by the SSN. Well, does it? Well, yes, because the ones that are equal are 1 and 1, and they are sorted here. And if I want them to also be descending in the descending order, now even when they're equal, I would like to start with the larger first, and then, so this is what this order by is going to be used for. Now, one thing that I would like to talk, which is not here, there's something that is not mentioned here, which is having, and we have not put any condition on it, used it yet. And this is going to be the last one. The having is, you remember this when I counted things? Like, for example, I'm just counting here this DNO. All of them are null. Well, let me go back to, I was using this, for example, the sex and s. Okay. Now if I do something like this, basically it gives me, it counts how many. Now what if I don't want, I would like to put a condition on this count here. I don't want to see all of them. I would like only to see those that have a count greater than 2, for example, greater or equal to 2. Which means I'd like to see all those records that have this value of the count greater than 2. Which means I'd like to put a condition on this result of this function. If I'd like to put a condition on the function, I cannot put it in the where. And if I'd like to put a where with the group by, the where should be before the group by. That's also something I did not mention. But you have to select from where, and then the group by comes after. But where, if I'd like to put a condition on this, for example, greater or equal to 2, I only want to see or greater than 1. Now this is not working. Invalid use of group function. Why? Because you cannot put a condition on a calculation on this aggregation function in a where. Where are used for columns, so I have to use something else. What is that something else? It's something having, but the having needs to be after the group by, not before. So let's just do this, and then I'm going to talk about the sequence. Now you see, I put a condition. I'm not seeing the other ones that are less than or equal to 1, and I'm only seeing those that have this greater than 1. If I put greater than 0, for example, now this condition will include also the female. So that's how you put these conditions. So now let me summarize a bit. We have, you know what? I can find it here. I have select, but it's not going to be easy to. And then I have from. Then I have where. Then I have group by. Then I have the having. Then the order by. And the last one is the limit. And there's a lot of different things that we don't want to talk about. Done. So this is how we're going to be. I don't want to. Yeah. So this is what we're going to be doing every time. Select from. This is the minimum. But you can have select from where, and then select from where with the with the order by, or select from with a limit. So, but if you have to use them all, this is the order that you need to use them with. Select from where, group by, having, order by, limit. And that's pretty much it. So this is something that was not mentioned here. Probably you can find some other ones later. Now, before we finish, I just would like to talk about these tables. Maybe let's just use this, but there are no examples, but I might use some of those examples. There are different ways how you can join different tables. Basically, what you would like to do, you have two sets. What do you like to do? Just the ones that are, I mean, common to both sets, or the ones that are all of them, including the one that are common, and all the ones that are not common to the others, or maybe just one and the common ones from the other one, or the opposite. And these are the type of joins that sometimes we get. And well, they have this with this example, which is, I don't know, let's have a look at the tables that they're using, this top list or whatever, the top hit and song and things like that. But I'm not sure that this is a good example. I think I can find maybe some better ones. Unfortunately, the ones on the slides are not, I mean, there are no examples at all. Just talk to you about whatever it is, and there's no examples. But I'd like to see, I think I remember that I found something. SQL join, or let's say left join, left and right join. Okay. No. Maybe this is where I saw that. Okay. Yeah, for example, when you have something like this. Now, the left join is because I would like to have all what's in table 1 and only the ones that are related from table 2. And this is something that can be meaningful. For example, if we have this kind of example, we have a customer, an order, and this is going to give me all the customers, and if they have some kind of order, it will give me the order ID. And those that do not have any order, I just would like to have also the customer name also listed. If I just do the join in the way we do it, it's just going to show me, now if I join these two, it will only show me the customers that have an order. Because if these are the same, it's going to display them. Customer ID 2, okay, this customer ID 2, okay, display it. Customer ID 1 is not here, I'm not going to display it. So it's going to display only the customers that have an order. But what if I'd like to display all the customers, but then only the order that is associated to those customers? That's why we sometimes would allow to use this left join or right join. And this is one of the examples. So now if we look at this thing, I don't know if I'm having unfortunately I don't have any data in my database. I could have used that, but there's just this employee. There's not going to be enough. There's nothing in department, so I cannot use that. Select star from department. I think I have nothing in it. Anyways, so the main idea is, so we're going to be maybe doing some more exercises on that later, is that if you have this left join, the left means that this table on the left of this join, that means this is the one that is going to be displayed completely, and the one on the right is going to be displayed only if there's some kind of association with it. Now if we look at this here, these are the two tables. This is the customer and this is the orders. I'm joining these, and what am I displaying? I'm displaying the customer name and the order ID. Okay, so I'm displaying customer name and then order ID, which is from here. Now what is going to happen, because it's a left join, I'm going to display all the customers, which is 1, 2, 3, and probably there are more, because as you can see 37, 77, this should be also some customers there. So it will display all the customers with all their names. And then those that do not have, for example, like this one, he does not have any order. What do we display on the order ID? Null. Because they don't have any order. So it will put null values on the corresponding if there is no relationship. But if there is a relationship, it will give me the value that is related to. For example, these two, I'm going to see this unnatural low and then 10308 in the order ID. This 3, I'm going just to see the name and nothing, null in the order ID, etc. until it goes. And this is what this left join. And the left join can be converted to a right join just by swapping the tables around. So this is a left join, but I can have, let me just paste it. This is a left join that I can be converted to a right join by just making this right, and then change this, put it here, this one, put it here, and that's exactly the same. Because now I'm displaying everything from the right, what is on the right, customers, and only those from the left that are related. So a right join and a left join is just the same thing basically, but it just flipped around. And the other type of join that we use is the way that we just used to do. If we remove this, that's the inner join that we're using, or the natural join. And remember, I said that there are two ways how to represent this linking, this joining between two tables. There's one way to do it like this. The other way is just to put the comma and put the condition in the where. Now there's no where, I'm going to put one. So if you put the condition that this is going to be just not like a left join, it's going to be like the inner join, or this if you join them. Well, fine, but if you would like to do them left and right joins, there's no other way but to use the join. But yes, you can use this maybe because you're more comfortable with this one. Yeah, so you can use it, no problems. But this means that you're only going to display basically only those that are in common, which is, if I find, yeah, which is this one, the one in the middle. When you do this, that's what you're looking for, only the ones that are in both relations. But if you want something else, well then, yeah. There's this full join. This is the one that gives you like this one. Full join means it's going to give you everything. What is, no, it's not going to be repeated. For example, let's say the full join between this customer and order. Now what is going to happen, let me maybe start with this paint. Now if it was the left join, right? If I said left join, so left join means I'm going to have the customer name and the order. I'm going to list all the customers, all of them, and then only the ones that have some value. So I have some value here, this is null, this is a value, this is null, so it's going to be having some null somewhere. Now the right join is going to be doing the opposite this time. For example, if I check the right join of the orders, it's going to show me all the orders, and also the other ones are going to be the customer that are not associated with that. But the full join is going to give you each one of them. It's not a good example with this order and customer because the full join is not going to be very easy to see. But I think I'm just retracting this example. It's not going to help you. It's just confusing you more. But for the full join, you got it. The idea is that it displays everything from the table on both sides, and those that are related are not going to be displayed duplicated. They're just going to be there too, because we display everything from all of them anyways. But what generally we use are basically the left and right joins, because sometimes you would like to have the list of all customers but only the information that is associated with them, because if we don't do that, it's just going to remove some of the information we don't have. For example, if we don't do this, we're going to see only the customers that have ordered something. But what if I'd like to see all the customers and only the ones that have ordered something, I'd like to see the extra information about them. So that's why this left and right join comes handy. Yeah, and that's where I'm going to stop, inshallah.